All right, we want to verify that tangent squared theta over 1 plus secant theta is equal to 1 minus cosine theta over cosine. All right, when I look at this, I don't see a lot, but I do see a tangent squared, which makes me think, and it also has some secants in it too, that makes me think that one Pythagorean identity might be useful. What is it? 1 plus tangent squared equals secant squared. So if I subtract the 1 over, I get tangent squared equals secant squared minus 1. So I can replace tangent squared theta with secant squared theta minus 1. And then I have 1 plus secant theta. I'm going to leave the right side blank for now. I'm not sure if I want to work with the right side yet. We'll see. Now let's see. On this, that's a secant squared and a minus 1. Oh, that's a difference of squares in the numerator. So we can factor the numerator. Difference of squares. So square root of this is going to be secant theta, 1. And then secant theta plus 1, 1 plus secant theta, those are the same thing. Those can cancel each other out. So I've got, I don't know what just happened. Where did it go? There it is. Huh, that was weird. So I just have secant theta minus 1 on the left side. Okay, I don't really know what else to do with that left-hand side, so now I'm going to switch over to the right-hand side and see if I can get anything happening there. On the left-hand side, I have 2 terms, secant theta minus 1, and on the right side, I only have 1 term, so I'm going to split that up. Okay, since it's the single denominator, I can do this as 1 over cosine minus cosine over cosine. 1 over cosine is just, I think that's going to be my last step. 1 over cosine is secant theta, and cosine over cosine is 1. So I'm left with secant theta minus 1, both sides. All right, let's check out number 7. We have tangent cubed x equals tangent x, secant squared x minus tangent x. Well, the right side is more complicated, so let's start there. I do notice that they both have tangent, so I'm going to try just factoring out the tangent. So if I pull the tangent, that leaves me with secant squared x minus 1. I think this is going somewhere well. This reminds me of Pythagorean identity. Remember, 1 plus tangent squared equals secant squared. So if I subtract that 1 over, I can replace this secant squared minus 1 with tangent squared. And then I still have this tangent. And of course, tangent times tangent squared is tangent cubed x, which is the same thing that's on this side. So we didn't have to deal with the left side. We're just done there. All right, one last one of these. We have sine cubed times cosine to the 4th equals cosine to the 4th minus cosine to the 6th times sine. I'm going to try and see if the same thing works. Can I factor out of the right-hand side? So this has cosine to the 4th and cosine to the 6th. So let's factor out, and I can do it at the beginning. Let's factor out a cosine to the 4th, which is going to leave us with 1 minus cosine squared. Oh, and I think we're there. This should make you think of your Pythagorean identity, that sine squared plus cosine squared equals 1. And so if you subtract the cosine over, you can replace this with sine squared. Okay, so we have cosine to the 4th x times sine squared times sine. And that's going to give us sine squared times sine is going to be sine cubed x, which is the same thing we have over here. So we're done. Okay. Again, there's just a lot of different tools that you have that you can try things. The important thing is that you're just trying something. I've given you a lot of different examples. They take practice. They take practice to recognize, should I factor? Should I use a Pythagorean identity? Should I rationalize the denominator? I encourage you, just try something, and it's going to start you on a path towards a right answer.